This is lesson 10.64, special segments in a circle. Your objectives are to take segments that intersect a circle and each other and calculate their length. Anytime two segments intersect a circle and each other, they work in this way with the formula IC times IC equals IC times IC, where IC means the distance from the intersection to the circle. The first IC is on one segment from the intersection to the circle. That will be 5. The second IC is that same segment from the intersection to where it hits the circle again, which would be X. For the other side of the equation, the next IC is from the intersection to the circle on the other segment, which would be 11, times the last IC from the intersection to the circle on the second segment as well. To work this out, we have 5x equals 121. Divide both sides by 5, and x equals 24.2. From the intersection to the circle is IC. Do both ICs for one segment, and then that equals both ICs for the other segment. Here's another one. Write the formula IC times IC equals IC times IC. Pick a segment for your first IC. We could do the one with 8 and X. So the first IC is from the intersection to the circle, which is 8. The next one is that same segment from the intersection to where it hits the circle again, which is X, equals, go to the second segment now. From the intersection to the circle is 4, and from the intersection to the circle is 9. Now solve. 8x equals 36. Divide both sides by 8, and x equals 4.5. This also works when the lines intersect outside the circle. Write your formula. IC times IC equals IC times IC. We'll use the top segment first. The first IC from the intersection to the circle is 10. The second IC from the intersection to the circle again is 10 plus 8, which will be 18. We had to do segment addition there to get the length of the whole segment. Equals the next segment from the intersection to the circle is 12 times from the intersection to where it hits the circle the other time is here. 12 plus x. Do segment addition there. And because that's a sum, we need to put that in parentheses. Now solve. 10 times 18 is 180. Distribute here. 12 times 12 is 144. And 12 times x is 12x. Subtract 144 from each side. And 36 equals 12x. Divide both sides by 12. And your final answer, x equals 3. For these, make sure you do segment addition to get the length from the intersection to the other side of the circle. 10 plus 8 is 18. 12 plus x is 12 plus x. Here's another one. Two segments that intersect a circle and each other. We're worried about segment lengths, so we use IC times IC equals IC times IC. For the top segment, the first IC from the intersection to the circle is 15. The second IC from the intersection to the circle here is 15 plus 17, which is 32. Remember to do segment addition there. For the second segment, the first IC from the intersection to the circle is 14. From the intersection to the circle again is 14 plus x. And because that's a sum, we need to put it in parentheses. Now solve. 15 times 32 is 480. 14 times 14 is 196. 14 times x is 14x. Subtract 196 from each side. 284 equals 14x. Divide both sides by 14, and x is about 20.3. Remember, from the intersection to the circle, when you're doing segment addition, add the parts together. 15 plus 17 to get 32. 14 plus x to get 14 plus x. Here's another situation where two segments intersect the circle and each other. So we will use IC times IC equals IC times IC. On the top segment, from the intersection to the circle is 20. From the intersection to the circle again is 20 plus 25, which is 45. On the bottom segment, from the intersection to the circle is x. And from the intersection to the circle again, the only choice we have here is to do x again. It's the same distance each time there. Now solve. 20 times 45 is 900. X times x is x squared. To undo a square, we square root each side. So x equals 30. Remember, from the intersection to the circle, when you do segment addition, add the parts up. 20 plus 25 is 45. And on the second intersection to the circle here, the only choice was to be another x. This formula works for all three of these situations. When they intersect outside with a secant and a tangent, when they intersect outside with two secants, or when they intersect inside with two chords.